Hello, I'm Foster. My teammate is Nemo and Alex. We want to introduce multimodal emotional recognition model. The advancement of the large language model, people are increasingly applying them in the field of the emotional dialogue. So the emotional analysis AI become more and more important. Let's look to use case that current AI cannot prefer well because they cannot capture the real-time emotional change of the user in the QA stage, and the user become angry and dispirited because it get the wrong result in the QA stage. So we want to achieve that the model can capture the real-time emotion change and make the user comfortable.
Okay, hello everyone. Let's talk about the related works and weakness. So, a common problem for all the mainstream models like LM-based emotion models, SER, FER, they're all able to achieve streaming emotion recognition, and the granularity of the emotions is generally not fine enough on sparse cross-grain classification. And the most models do not support the simultaneous input of the complete three modalities like the audio, video, and text. And let's talk about weakness of the current data sets. First of all, the framing, the conversation is too short, and then its data annotation is rough. The details of the annotations are insufficient. The quality and the consistency are low, and it's difficult to capture complex emotions. And thirdly, limitations in data collection. Over-reliance on laboratories or predefined scenarios leads to low electrical validity and detachment from the real world.
Okay, I'm Lemon Guopengze, and I will describe the rest of our project. Our tasks include two parts. First, emotion prediction using text, audio, and video to classify emotions at both 7 classes and 28 class levels. Second, streaming emotion prediction. As continuous multi-data arrives, the model outputs real-time emotion states for each segment, and after the session ends, provide the overall emotion and key transitions point. This enables a truly dynamic moment-to-moment emotion understanding. So exciting emotion data has 3 issues: poor and inconsistent labels, unnatural emotions from interviews or labs, and privacy risks in real-world data. So we're using TV programs and films which give us a rich and natural emotions without privacy problems. So our data has 10,000 clean samples. We fix the 1,000 MELD clips and relabel the CH data. MELD has many short sounds that depends only on the context. Like our picture shows, not the sound itself. So they become a noise for pure emotion tasks. We manually labeled 15,000 labels and build a multi-level emotion system, 7 basic classes and 28 fine-grained Go emotion levels. The data is trimodal and bilingual, video, audio, and text in both Chinese and English. So we first tried multi-modal AI models like Qianwen and ChatGPT and Gemini to help us label data, but they worked poorly on fine-grained emotions, only about 0.5 F1 score. So we dropped automatic labeling and moved to a full manual work. So we're using a strict 3-step process as the picture shows. 12 annotators label each symbol 3 times, and we compare these 3 labels, and if they didn't match, the sample will went to the experts for the final decision. This ensures a clean and reliable human labels. Our model encoders video with clip and audio with Hilbert. Then after the linear layer combine these features with text and prompt, all fields input are fed into Llama 2 to produce a final emotion prediction. So before fusion, we pre-trained clip and Hilbert so they can learn strong video and audio features. Each encoder is fine-grained as the filter extractor, aiming to capture meaningful emotion expressions. And then after this, we freeze the clip and Hilbert encoders, train the middle linear layers, and apply LoRa to Llama 2. This lets the model learn emotion features sufficient without updating the heavy encoders. To support streaming, we must first cut the text into small units using EDO segmentation, which splits the text into the smallest meaningful pieces for real-time processing. In our streaming design, we keep the hidden state for every test stress. This test model uses the path context for both the intermediate predictions and the final decision. It also saves time because we only need to encode the new coming part instead of re-encoding everything. This incremental process keeps our streaming system accurate and for real time. Due to the time emission and resources limitation, we did not conduct a compare training process, but only validate the feasibility of existing framework. Our data has been funnel annotated, and we use it to initialize our Hilbert and Clip encoders to verify if this current tensionic approach can capture the emotion features. And the detailed content of process are available on GitHub and our ACL report.